So today I'm going to give a presentation about how to use the Monsoon supercomputer. And yeah, I'm going to start by sharing my screen. And as I go through these steps, I encourage you guys to follow along on your own computer if you can. And stop me if you have any questions about what I'm doing. So what I do first is, here I have my blog called Our Batchtools on Monsoon. If you go to my webpage, you can click blog and then search for Monsoon. And then, that's the blog that we're going to be working through today, adapting slightly. And so, yeah, I mean, the idea here is that, we're going to be using this Monsoon supercomputer, which, if you know something about supercomputers, it's not super complicated, actually. It's just you SSH into this machine, and then you get some special commands that let you run other commands on compute nodes. So you can think of it as just like, you have a desktop computer that you just built recently, right, Joe? You can think about like a room full of those guys, and that's what a supercomputer is. They're all kind of connected to the same disk, and they all have the same file system, network file system that you can load your data onto and do computation on. And that's basically it, so it's just kind of a nice interface to do, to access a lot of CPUs. So yeah, this is important in machine learning research because, often we want to do some kind of analysis for a bunch of different data sets, or for a bunch of different trained test splits, or for a bunch of different algorithms. And in all of these cases, we can do the computations in parallel over all of those CPUs on the cluster. Yeah, cluster or supercomputer, or these terms are interchangeable. And yeah, so any questions about that before we get started? Okay, so yeah, so the first thing you got to do is you got to connect to the NAU VPN. So I've already done that. You can see, I don't know, on Ubuntu you get this little lock icon when you're connected to the NAU VPN. And so what that allows you to do is you can pull up a terminal. I've got this terminal going right here, and we can do SSH-X username at monsoon.hpc.nau.edu. And so what that means is to do a secure shell with X forwarding using this username at that host, right? So it's going to ask me for my login. I put in my standard NAU password, and then I get this prompt that says, "Welcome to Monsoon. You are logged in as CH798, that's my username," and has a few other announcements. And then it has the prompt here. So it says that I'm on Wind. Wind is the login node. The login node in cluster etiquette is this node that you get kind of sent to when you first log in, but you're not really supposed to do any computations on. So if we look in the tutorial, we can see that, actually in the tutorial I'm doing here, let me make the text bigger so it's easier for you guys to see. Is that okay? Text okay, guys?
Looks good to me.
Yeah, same.
So here it says SSH-Y instead of SSH-X. And so I think the difference between the two is you have a secure X forwarding versus insecure X forwarding. I think the secure one is the X, insecure is a Y. And so in Windows, for some reason, that -Y is what works on my computer. On Linux, I'm using the -X, and that works fine. Anyway, either way, you should be able to get it to work, whatever system that you're on. And you should be getting this prompt like we just saw. And like I was saying, we get to this wind login node, just like I wrote in the blog. And, basically the first thing that you should do is to like start an interactive job on a compute node, because you're not supposed to run any compute intensive jobs on the login node. So, going to the login node, we can kind of see what's running on the login node by running this htop program. I don't know if you guys ever used that, but you can see that by looking at the htop output, you've got 24 different processors on this login node, and most of them are kind of hovering around 0% CPU usage, except for this one over here. And so, I mean, that's pretty much how it should be. You're not supposed to do any big computations on the login node. There might be some people who are like using a text editor or doing some copying of files or something. But if you're going to do any computations and use some CPUs, you should be doing it on a compute node. So let's do that. But before we go on, did anybody actually follow along? Are you guys logged in on the Wind now or no?
I don't have a login, so I got to figure out how to get one.
Yeah, I did.
You follow along, Akila? You're on Wind?
Yes, I do. Yeah.
Good job.
I did.
Good job. So you guys keep following along. And tell me if I'm going too fast, okay?
Mhm.
And so yeah, the next thing we just do is this srun-t command. So I'm going to copy that and paste it into my terminal. And so what is that? Oh, so it just ran right away. And so it says srun-t24 mem equals 4 gig, CPU per task equals 1, PTY equals dash. So what does this mean? This means we want to get a compute node for 24 hours, and we want to have 4 gigabytes of memory available on that compute node. We want to have one CPU for doing computations, and then the command that we want to run on the compute node is going to be bash. So we get a shell on the compute node. And so this is what we see. We get a prompt on compute node number 68. And if we run htop now, we should be able to see that there's something quite different. Well, first of all, we see there's 28 CPUs instead of 24, I think, whereas on the login node. And now we can see that there's a bunch of CPUs that are maxed out at 100% usage, right? And so that's because, all of these compute nodes are shares. So, I mean, basically there's a scheduler program that says whenever, somebody asks for a job, well, is there any space on this node? Well, yeah, sure. There's only, I don't know, 10 CPUs being used. Let's put Toby on this one because there's plenty of space, right? So, so yeah, did you guys get onto a compute node too?
I did it.
Yeah, which one are you on? Are we in the same one?
Oh, right now I didn't. Earlier I did.
So srun will just assign you to one wherever, like you don't really specify it.
You can ask for one in particular if you want, but the whole point of the compute cluster is that you don't ask for specific computer. You ask for specific resources, and then the scheduler decides what computer you could use.
Yeah, because it doesn't really matter. You just need the resources. Looks pretty cool.
So Sue, did it work for you? Are you on a compute node now?
Yeah, we're at the same one.
You're on 68 as well?
Yes.
Wow, that's interesting. So so now what do we do? So now we can run whatever we want on the compute node. And sometimes you'll see this message queued and waiting for resources or has been allocated resources. If it takes a long time to queue, or sometimes if all of the CPUs are being used, you're gonna have to wait before you get your job running. But in this case, and in actually most cases, in my experience on the Monsoon cluster, there's plenty of spare CPUs, and they'll just give you one right away. So the next thing that I usually do is open up emacs. So emacs is this text editor that I use for writing code. And so emacs, and that actually will open up emacs in a X window. So it's forwarding the X window to my current to my laptop here, so we can actually see, you know, actually, so this Emacs here is running on the cluster, and so any computations that we do inside of Emacs will be run on that compute node instead of actually on my desktop computer, so my laptop computer. So the other thing that you might want to do, if you're not an Emacs geek like me, you might want to do module load RStudio, and then RStudio, and that should, for those of you who do R code development, that should give you kind of a graphical interface for writing R code in more or less the same way as you would on your own computer. The caveat being, you're going through the VPN, and so it might be a little bit slower than what you're used to, right? So that's one of the advantages of learning these, other programs like Emacs. You can use this, and it's usually a lot faster than RStudio over X forwarding on the cluster. And so here I'm just going to.
I have a quick question or an aside.
Yeah.
Maybe for a different presentation, you can talk about the differences between like Emacs and Vim and why you prefer Emacs.
I can't talk too much about Vim because I don't really use it, but I could give you a demo about Emacs, yeah.
Because I was thinking about picking either one up, and I'm just trying to make a choice. So.
Emacs.
Oh, good. Now I know.
Anyway, so I'm going to close RStudio because I'm not going to use that, but that's an option for people who do want to use it. It will be a lot more fast and responsive if you do it on the NAU network rather than over the VPN. Especially if you plug into an Ethernet, it's usually just as fast as if you were doing it on your own computer, but over the Wi-Fi sometimes it's a little bit shaky. Anyway, so now I have my Emacs window, and I can use it to do whatever computations I want. Let's go back to our tutorial and see what the next thing we should do is. There's a little bit of explanation about how to use Emacs and ESS, and there's a few links there. Some suggestions about how to install other software. So here I say, if you want to, use Anaconda, you can do module load Anaconda 3 and create a Conda environment and do Conda activate, and you can use that to install a lot of packages that might be relevant to doing the computations you want to do. Like for example, Sue is doing Anaconda with PyTorch, and so that's a deep learning library for his research project. Then I have a little bit more code about some configuration. It's worth it to spend a little bit of time, like putting this kind of code into your bash RC file. So if you look in my bash RC file, I've got something similar. So this is my bash RC file on the monsoon cluster, and actually, so I've got the PS1 that's telling the shell what prompt I want, and so if you look at the shell I have here, we have this kind of thing that says your username at the computer name, and so that, the kind of the code for that is \u at \h, where the u is the user and the h is the host name. And then if I was in a Git repository, it would be telling me what Git branch I was on using this parse Git branch function. So that's sometimes useful too. Another thing that I usually put in my bash RC file is this module load R and module load Emacs. And so that's going to give me kind of access in all of my shells to this software, which I use kind of all the time. So like, for example, Sue, if you're always using Anaconda, you can put in your bash RC file, module load Anaconda 3. So then it's loaded every time you log in, and you don't have to type that every time on the command line. Does that make sense, Sue?
Yes.
So is this, would this like run every time you logged into your compute node, or I'm a
Every
little
time you
confused.
open a bash shell, this is the code that's run. That's in the bash.rc file.
Oh, okay. And then the compute node is running bash.
Yeah, yeah. I asked it to do that. Yeah, if you recall up here, I remember I asked it to run the bash shell. That's the default shell, I think, anyways.
Right.
Anyway, so yeah, I recommend that you do that if you haven't already, so it's kind of save some time, do some configuration. And explain a little bit, I also do some configuration in my R profile, options, repos, so then you can install packages easily from this cloud.rproject.org. And then it says you can do install packages, batch tools, and so this is the R package that we're going to be using to launch jobs on the cluster today. And so what is batch tools? The batch tools is this pretty cool R package which gives a bunch of functions that let you, kind of execute your R functions in parallel on different cluster nodes. And so yeah, the main thing that you need to kind of learn to deal with batch tools is this concept of a registry. And so the first thing that you want to do when you're using batch tools is, you want to do this make registry thing. It's going to create this registry directory that kind of creates all of these like, files for interacting with a cluster. And so it's going to take care of all of the details of, generating these shell scripts that we need to interact with the Slurm job system. And so we're not going to have to write those scripts ourselves. The R code is going to write it for us. So that's the kind of main advantage of using batch tools, and it's going to be able to interact with lots of different kinds of cluster systems too. Like, so you don't have to learn, if you go to another university, they might be not using Slurm on the cluster, they might be using PBS or some other cluster computing system, and in that case, the batch tools, it interfaces to all of these systems, so you only have to learn batch tools, and then it takes care of the details of interfacing with whatever cluster system that you're using. But yeah, before we run that code, let's kind of like give an example of using R interactively on the cluster. And so the example that I wanted to give is from this introduction to supervised change point detection tutorial that I gave a few years back. And I've got some code here that I'd like to show you. So I mean, the goal here in my tutorial is to do something similar to this analysis where, I have this ROC curve where I'm plotting the true positive versus the false positive rate for a bunch of different change point detection models and for different test folds for one data set. And so kind of my goal of this tutorial was to show you how to do the same kind of computations in parallel on the cluster. And so let's go to the R console, and I'll show you how to maybe do that. So first of all, I created a little demo directory, and so in my code here, the first thing I do is I kind of doing here, I'm starting R, so now I have an R running inside of my emacs on that compute node, and I did this dir command, which lists all of these data sets in this directory, and so what I would like to do now is to kind of show you guys how to do the same kind of analysis on all of these data sets that I've already loaded onto a cluster. And so yeah, I guess the kind of details that I'm glossing over here is that when you do your analysis on the cluster, you're going to have to kind of copy your data files onto the cluster to do this, to do your analysis. Because I mean, typically, you're going to have to either download them or rsync them or SCP them or whatever. So I already have done this, and so that's I'm not going to get into how to do that today, but the idea here, though, is that I'm going to have, here, let's do, actually, I'm going to do sys.glob. And here I'm going to use some completion to look at all of the directory structures here. And so here I'm going to look inside, and there's a lot of these test fold directories. And what I'm going to want to do is I'm going to want to do this model fitting and then prediction and computing the test error for all of these test folds. And so if I use this sysglob command on all of these guys, we can see that there's 68 different of these different test fold directories. If I use the equal labels type of CV, but if I use all kinds of CV, we get even more. So there's 198 different test fold directories. And so this is the thing that I'm going to be wanting to parallelize over. So, for your cluster experiments, you're probably going to be doing something slightly different. But the main idea is that you're going to want to have like the first step be like, okay, let's see if we can get a vector of arguments where each element of that vector represents like a different job or a different data set that we want to do the computation on. So here I'm going to call this test fold der vec. So it's a vector of test fold directories. I'm going to save it in there. And so essentially what we're going to do is we're going to do something like for test fold der in test fold der vec, some long computation on test fold der, and then this is basically what we want to do, right? So the only difference is that we're going to be doing that computation in parallel on different CPU nodes using this batchtools package. Before I go on, are any questions about what we just did here?
So the main goal here is to split up like each of those directories, or I guess this is leading to like data sets, and then doing the computation instead of sequentially one right after another with that loop. You can split it up and do it in parallel.
Well, yeah. So we're not actually going to use that for loop. So let me just delete it because maybe that's confusing. But
because that would do it sequentially, like in
right
that kind of example.
Yeah. So yeah, what we're actually going to do, let's do prototyping on the code of just one of these. So let's just consider one of them. And so what is the computation that we want to do for just one of them? Well, if we look back at this this tutorial, I mean, basically what we're going to want to do is, everything, all of these commands that are inside of this for loop, right? So here we're doing the same kind of thing. We're doing the for loop over test folds, and every time, it's calling some code on these like features and targets, which are basically inputs and outputs in a machine learning problem. And so I guess our first task would be to read from the data files that we have on disk the corresponding, features and targets or inputs and outputs. So looking at this test fold dir thing, how do we find our data files? Let's do dir name. Dir name gives us this. Dir name again gives us this. So their name. Let's keep going back. So let's call this CV CV type dir, and then we do dir name again of CV type dir to get our CV dir. Let's do dir name again. We're just going back on this path. And so why am I doing this? Basically we're going to be plugging this this thing in, and so we're going to want to have some code that analyzes whatever we plugged in and finds the relevant data files so that we can do the computation. And so here finally, let's call this data dir, because this is the directory which is like kind of the main data directory. And then inside of this data directory, there's a bunch of files. Inputs and outputs are the ones that we're going to want to use. So let's take a look at those guys. So actually, you know, let's do a for loop over these guys. For file type in evaluation inputs outputs. So what we're going to do is we're going to read those files. So how are we going to do that? So file type is going to be one of these things, and so we can do file path. Let's call it. Let's first do xz file is paste 0 file type .csv, or let's do CSV file. Okay, so our CSV file is going to look something like this. Let's put a dot. And then the xz file gets paste 0 CSV file .xz. So xz file is this, and so we can say if file exists xz file, then we can run unxz. You know, this is this decompression program, so we can get a CSV file on that xz file. Let's see if that works. So let's run that code. And so I guess it did work. And so then what we can do is we can do data table fread on that CSV file. Or did it work? Because we didn't give a absolute path, right? So maybe it didn't. I think maybe we have to do file path. What is it? Data dir flat. Yeah, data dir. Let's see. File path data dir CSV file. So that's not working for some reason. So let's take a look. Oh yeah, so again, we have some funny thing here. Let's put the file path inside of here. So did that work? No. So what am I doing wrong, guys? Are you following?
Yeah, I had a similar issue.
Well, how did you fix that?
I didn't. I did it manually. I unzipped it manually.
Well, you need to figure out a way to do, so let's figure out a way to do this. Okay, so first of all, does this file exist? Let's call this xz path. So first of all, does it exist? Yes. That doesn't exist. So there's something that's going wrong. So why are we seeing that? Why are we seeing that exists in the right? So that it should exist, right? So there's like some typo or something, right? Where's the typo, guys? Help me out, please. Oh yes, that's XZ path. So that's what it is. So there it is. So this code was not being run because the file did not exist, right?
I see. Thank you.
Right? So let's see if that works. Okay, now let's try to do dir again. Dir, data, dir. What is this? So now we see we have outputs.csv instead of outputs.csv.exe. So that actually the decompression command worked this time to decompress the exe file to a CSV file. And then we can read this to say, okay, let's call this data list. It's going to be a list of these data tables that we're going to be reading here. So let's call data list. What is it? File type. File type gets data table fread. Okay, we have to initialize our data list first. So let's just do that thing. So then what is our data list? After we execute that whole for loop, we get, we get this kind of big list of 3 things where the first one is this evaluation thing. Second one is this inputs thing. 465 observations of 37 variables. And the outputs, 465 observations of 3 variables. So these inputs and outputs, these are where we're going to want to plug into our machine learning function. And then this evaluation file is we're going to want to use that for computing the raw curve. So let's see if we can do that.
Yeah.
Question?
Yeah.
You cut out
right.
for 10 seconds there.
Sorry. Anyway, so I say, well, we read all of the data files now into R as data tables. And now let's try to do this computation, right? So let's just kind of copy this code that we have here. And let's see if we can kind of adapt it to our use case with these data sets. Are there any questions about what I did about reading the data files?
So you read all of the data files in your, was it in that unzipped directory, and then put it in that data, that
I
list?
read those 3 files, yeah.
Okay.
Yeah, so the first thing that we do here is in this code, this is, code from supervised tutorial. And so first thing that we do is we're trying to select the subset of data that corresponds to the train set. This is not the test fold. And so here we have to go back to the beginning and we look at what is our test fold dir look like. And remember we have this number 1 here. And so that number 1 indicates that we're doing test fold 1. And so let's call this test fold ID. And so that's going to be base name of test folder, right? So test fold ID is going to be like this, just number 1. And so what are we going to do with this guy? Well, we're going to have to look at this. I don't know if you noticed this, but we have this CV type dir, and inside of the CV type dir, we had this file, which was called folds.csv. I don't know if you ever saw that, but let's just take a look at that. Data table fread folds.csv, and this is basically got it tells us what for every one of these 465 observations in the data set, which of the fold IDs it corresponds to. So if we save that in, let's call this folds.dt, then we can kind of go back here and we can say, okay, let's select all of the folds which are not, let's see, fold not equal to, what is it, test fold ID. I think that's what we have. And then let's select the corresponding sequence ID value. So let's call this train seek ID. So then our train seek ID variable is this this vector of 335 IDs, which corresponds to all of the data which are not in the test set, right? And so what are we going to do with that guy? Then we can, use that to subset our features and our targets or inputs and outputs, like we have from these data files here. So let's call this train outputs. This is going to be equal to what a data list outputs, and again we can do sequence ID, and then or I guess no, actually we let's select all of them which correspond to train seek ID on, and then do on equals sequence ID, and that's going to give us this train outputs DT, which is just this data table of 335 rows. So this is an interval regression problem. So the labels in this case are this these two columns which give us lower and upper bounds in our regression problem. So I'm not going to go into the details, but the idea is that we're going to be plugging these in. So this is, let's call this, just to be consistent with our notation below, let's call it train target DT. And I don't know, maybe actually just use outputs. Train outputs DT, and then here, maybe get rid of that. Here we're doing train features. So let's take a look at that. How are we going to do the same thing? We'll just do the same thing, but with the feature data table. Let's take a look at that. So, or with the inputs data table. And so, that one, it's going to be, similar. We've got 335 rows and 37 columns. And so those are the features that we're going to be plugging into our machine learning function. So here, I'm going to modify the code. So we're using train outputs DT, and we're going to select this min log lambda, max log lambda columns here. So we're going to be using that in our training. And so let's just do that. Let's see what happens there. Then we get this matrix train target mac, which we can plug into our machine learning function down here. And so let's do that. Here I'm going to do, so here it's plugging in the features, some feature names. So let's just do train inputs DT, and let's just select all of them except for the first column, I think. So actually, let's look at the names to make sure. But here we have, a bunch of features, and the first column is the sequence ID column. So basically, we just want to get rid of that one and use all of the other ones. So let's see if we can do that. So again, let's do this -1 thing, and maybe do as matrix. So then we can see if we can get a matrix there. So let's call it train inputs map. And so what is this? This is this matrix of, with one row for every one of the train observations, one column for every one of the features. And, we can just try to maybe plug that straight in to this function, train inputs map, train target map, and let's see what happens. This is the machine learning function I'm supposed to learn from these guys. So this is kind of a, maybe these kind of steps you could do on your own computer to to kind of, you know, kind of debug your code before you plug into all of this stuff. And so I'm just doing it on the cluster to demonstrate that you actually can do all of these things on the cluster interactively as well. You know, you can do this on a compute node, kind of in the same way that you would do on your own computer. Sometimes it's easier to just do that. Anyway, so here we have our model fit object that we can use to make a prediction. And to kind of, let's see if we can do these other ones too while we're at it. So train target AT. Well, actually, you know, we're kind of running out of time. So I think I'm just going to kind of get rid of the rest of the code, and let's just do our computation using what we've got here. So ideally, you're going to have some more code that, in addition to fitting your model, you're going to do predictions on the test set and all this stuff. But I'm going to omit that for you know, for time. But the idea is that here we've got some code that's reading the data and some code that's computing our machine learning model. You know, to do also compute, test, error, accuracy. But you know, the important like last thing that you want to do here is that you would want to like do some kind of like saving your results. So here I can use save RDS on this fit object, and you would want to save it to some file like underneath this test fold directory. So let's say called file path test folder slash results.rds or something like that. So then we have the results and we can access them on the disk after we're done with the computation. Anyway, so all of this code we want to do in parallel, right? And so what we want to do is, here I'm going to create a function called onefold, and here I'm going to say that this takes in one more argument called test folder, and it's going to run all of this code, and it's going to finish by saving that RDS function. And so this is the function that we're going to parallelize on the cluster. So any questions about that before we do that? So let's just do it then, yeah? So going back to the batch tools, you know, here we've got some code that says, you know, batch tools make registry. So let's do that. So first thing that we want to do is we want to do this make registry, and that's going to kind of create this registry dir, which is kind of, again, a bunch of files that we're going to be using to interface with the cluster. After that, you know, it says, right, it says that it's sourcing configuration file batchtools.conf.r, and just very briefly, you know, I've already set it up in my home directory so that, you know, there's this kind of user-specific batch tools configuration file that says every time I want to run batch tools, it's going to use, you know, the slurm cluster functions. That's what it's called. So it's going to be, you know, when we tell it to run the job, it's going to be asking the slurm cluster system manager to do it, and it's going to be using this template, which is basically, you know, a shell script that gets filled in with variables that we're going to specify in our code about the resources we want for our job. Then, yeah, so the next step that we want to do is, you know, so all of that is done for us when we do that. And so the next step we want to do is this batch map function. So this is going to be the function that's going to say, these are the jobs we want to run in parallel on the cluster. So let's do that. So batch tools, batch map. And so here we specify the first argument, the function onefold, and the next argument is, you know, you can use a bunch of different options here. I'm not going to explain all of them, but the idea is that you can just specify this vector of, you know, test folds to do, and it's going to, you know, basically add all of those jobs to this this registry, which is going to kind of keep track of what we want to run in parallel on the cluster. So, so I say note that they're not running yet; they're just declared. So, So yeah, that's what we're going to do. And so here's an example of a function that we use. And so I had another function that we just coded that we use. And so after we have declared the jobs, the next thing that we probably want to do is this test job thing. And so test job is going to like run a job, but not on the cluster, but just like right here, just to see what happens. And so this is a good reality check to see if, you know, your code is actually running without errors. And so if this kind of stops with an error, then that kind of will tell you, hey, I should go back and fix this one fold function. Maybe it's not working like I thought it was gonna work. You know, that's probably gonna take just about as long as it did to do that, you know, interval regression CV when we ran it interactively. And it looks like it actually worked. And, you know, to check that it worked, you know, we could actually look in that, what is it, test fold dir directory, and we should see that results.rds file, right? So that was written at the end there by that saved RDS at the end of that one function. So that means that the job actually worked. And so finally, to launch the jobs on all of the different compute nodes, what we do is we do this submit jobs thing. And here, what we do is we specify all the resources that we want for our jobs. And so, yeah, actually, so we have to do this chunks as array jobs thing. So let's do that. So that's actually an important point. So when you've got a lot of jobs, it makes a big difference if you're using this array jobs mechanism. And so you really need to do this. So here, this thing gives us this job table, which is a data table that describes the jobs which we want to launch eventually. And then after that, we get this chunks table, which is just the same thing, but with an additional column, chunk equals 1. We can see that this one column at the end here. And that just indicates that we should use all of these guys in the same job array. And so that means that they will all launch together quickly, very efficiently. And so then finally we pass that chunks object, which is this data table we're looking at right here, to the submit jobs function, and we specify the resources that we want. So here I specify that we want 24 hours, here 2,000 megabytes per CPU, one CPU, one task. So that, you know, typically we are always keeping this at 1 unless you want to have multiple CPUs inside of your job. And then the chunks as array jobs equals true. This is again for making sure we're doing this efficiently. So let's see what happens if we just launch it like this. So it says submitting 198 jobs in one chunks using cluster functions learn. So after that, we can actually start, you know, they may be computing already, they may not, but what we can do is we can do this batchtools get status command, and we can kind of check to see what's happening with those jobs. So it looks like, yeah.
1 second. So you specified the number of CPUs equal to 1. Does that mean the number of CPUs per job?
Yeah.
Okay, thank you.
Yeah, so the resources you specify is how much you're asking for each one of these calls to this function. And so, yeah, we can see that, you know, already there's 20 jobs that are currently running, 24 which are already done, 154 which got an error for some reason. You know, if we do get status again, maybe they're all done by now. And then, you know, the next thing that you should probably do is you can check for what these errors are. You know, this is pretty common to see some errors when you're doing these things. And when you're debugging your script, you're probably not going to get it right the first time. And so how do you debug the errors? There, it shows you a little bit how to do it on the bottom of the tutorial here. So again, you can use this get job table and then is NA error thing. So let's do that. So get job table and then is NA error. So what would that look like? So we can see, sometimes you can see that, you know, it says after filtering, so it tells you the error message, after filtering NA features, none remain for training. So, so what happened is that, you know, in some of these features, there's some missing values or some infinite values, and I forgot to do that in my function. So I can go back there and fix it if I want to get those. And so when we look again at the kind of the status, we see that there were some that did complete successfully. They're done, right? 35 jobs. And so those, I guess, were the ones where they're, you know, all of the features in the matrix were finite. So there seems like there's a lot of them that had that error. The other thing that you might see is that here it says argument specifying columns, specify non-existing columns. And so, yeah, maybe I forgot to remove this sequence ID column from one of them. But anyway, so you get the idea. So, you know, you can check the error messages using this this table, and you can see like which ones had the error messages in. So this is an important point. So, for example, you see there was an error on actually the first one that had an error is a job ID 9. And so that corresponds to going back here and specifying number 9 here instead of a number 1. And then you can go back and debug your code, going through line by line and trying to figure out, you know, what happened. And so if, you know, if everything's working fine, we should see that same error message that we got from the job. Yeah, I guess the error message happens right here. But yeah, hopefully, you know, that helps you do the debugging by looking back at that job error table, looking back what the job ID was. You can plug back in and run the code interactively again on the compute node to see, you know, exactly in the same environment, like what's going on. And then hopefully you can fix your code and get it running on all of the data subsets. And yeah, let's look at the tutorial again. Is there anything else you want to explain? You know, there's also this concept of expired jobs. I didn't really have time to get into that, but you know, there's this other status called expired. If you look up here, you know, you see there's no expired jobs here. And what is an expired job? That's like a job where you requested not enough time or memory. And so, you know, the scheduler had to kill your job after 24 hours because you only asked for 24 hours and it was going to take longer than that. So sometimes you see that happen, and sometimes you can use this, you know, find expired thing to get, to figure out which jobs that happened on. And so you can, you know, maybe rerun them or modify your code or just ask for more resources so that doesn't happen next time. Yeah, that also happens for, you know, when the system has to cancel your job, like for a seg fault or something like that. And yeah, so we're kind of almost out of time. So the last thing that I wanted to mention is that, you know, again, we have this, I'm going to open up another R while we're doing that computation there. But we have this, you know, we have this vector of testfold directories that we wanted to do the computation on. And then, you know, we can actually, you know, if we modify this thing, let's do a little modification. You know, we can actually just see what are the result files that we were able to compute. And so that's again, we save them as these results.rds files. And so you can see by doing this glob command that there should be, you know, here there's 42 result files that we've computed in parallel using this approach. You know, again, there were a bunch of them that got an error. And so by fixing the bugs, you can eventually get all the 198 result files. And then so the last step would be, you know, you have some kind of, you know, some code down here at the very bottom where you're doing, you know, results .rds-vec, and then you do something like, for result.rds in results.rds-vec, then you read RDS of your result.rds file, and then, do some, plotting or summarization or whatever, So the idea is that, when you're using the cluster, you're going to have kind of these three parts. The first part is, you define what are you going to do for each one of the subsets of the data that you want to work on, or each one of the different algorithms or whatever. You're going to have one function that does your computation on one small piece. Then you're going to have this other piece where it's like declaring your job to the batchtools system, and critically you have to specify that function and what the arguments to that function you want are going to be. And then after that, you do the submit jobs, where you declare what is the resources you need for each one of those jobs. And then finally, at the very end, you can do some analysis of how many jobs are finished and which ones have errors. And then after everything works fine, you can read all of your results files, and then get some results. And hopefully this will be faster than if you did it on your own computer, right? So, in theory, for this example, it should be 200 times faster, right? If we're able to access all, 200 compute nodes. So, so it can be substantially faster than what you could do on your own computer. So we're right about time, but are there any final questions or comments? Was anybody actually able to follow along?
I wasn't following along specifically, but I was watching the whole thing. It was definitely super cool, how you can basically vectorize Slurm operations.
Yeah, I followed, but it, I don't know. It's Python supports batchtools.
Yeah. So Sue's question is, how do we do this in Python? And so yeah, with Python, I don't know if they have a
Yeah,
they don't have batch tools, but maybe they have something similar to interface with the Slurm if you want to do that. But otherwise, they have some tutorials on the Monsoon.
Yeah, I followed tutorial from the monsoon.
Yeah, so they explain how to write the shell script yourself, and you specify the resources you want in the shell script header and stuff like that. But yeah, I mean, the advantage
you need to check. Okay.
Yeah. Go ahead.
But if some error with your code, you need to check each file. It's very complicated. Like in PyTorch, it has a rule named error, so you can check the rule of the job.
Yeah.
It's very fast.
Yeah, I see. So yeah, I mean, yeah, there's a couple advantages to doing it using the batch tools package, and so yeah, it's easier for error handling and stuff. Anyway, so let's just talk about what we're going to be doing next week. Yeah, let me stop the video. Yeah. Mm-hmm.